Buenas tardes a todos los que nos acompañan el día de hoy en el JConf Perú 2021. Espero que la estén pasando bien, que estén aprendiendo. Esperamos con la fase de las sesiones de charlas de la tarde. En esta ocasión tenemos con nosotros a Marcos Schulz, perdón. Él es de Alemania, pero radicado en México. Tiene más de 15 años trabajando en tecnología de Java, ¿no? Y tiene título de ingeniero de software, toda una gran experiencia en múltiples rubros de la tecnología. Y el día de hoy nos va a hablar acerca de Maven, desmitificando Maven. ¿Eso es correcto, Marcos?
Absolutamente, absolutamente.
Su presentación será principalmente en inglés, entonces estaremos pendientes de sus consultas, sus inquietudes que tengan al respecto. Y bueno, bienvenido, Marcos. Welcome to JConf Perú 2021. Go on.
Gracias para la invitación. Me encanta mucho. Okay, now I switch back to English because it's more easy for me to talk in English. My Spanish is not that good. Yeah, I talk about Maven POM, demystified, enhance your build, because a lot of developers, they're working in, or they're dealing with Maven. Often they run in problems and they don't know how to solve. And for this reason, I was creating this little presentation to give some insights how it Maven work, on how you could utilize in your project. And then after this talk, you get with a little examples an idea how to fix problems when they occur. So in this way, the presentation have two parts: a little about the Maven theory, and then at last I show some real examples, very structured. In the example part, don't hesitate to questionize me. If you have some questions, just let me know. I try to answer everything the best as I know. In this way, let's start now with some basic things about Maven. As first, it's very important that we keep in mind that Maven have some words, like a little language. We need to understand, and we need to use it, because as first, a very important word always we need to use is artifact. An artifact is not something complicated. It's just a little piece of software, binary, or you can use it equal like library, module, or plugin. In this way, everything means the same, but in the context of Maven, usually we talk more general, because we don't want to decide is a library or a module or a plugin or something else or application. We're just talking about an artifact. Then very important is Maven have three life cycles. There is the site life cycle. It's for reporting. This with the life cycle, with the site life cycle, you can create Javadoc and other reportings like code coverage, everything you need. There is another very simple life cycle called clean. This just clean up your activities you was doing inside of Maven. Finally, it's cleaning, or it's erasing a target directory and all the changes you was doing during your build. And the most complicated and the most common used lifecycle is build. And in this context, the build lifecycle contains different phases. A phases is something like a step you walk through inside of the lifecycle. So a lifecycle, the build lifecycle, you can understand like a workflow. And the workflow is divided in different phases, and each phase, after one phase is passed, the next phase is initiated. And they have a fixed ordering, so you cannot change the ordering. We will go a little later more deeply in the thing what means the build lifecycle and what is there very specific for it. So when you call a phase, you are binding a plugin into the phase. This plugin has several goals. or activities you can do. This you can call separately or directly. In this way, you have to keep in mind there is the build lifecycle. The lifecycle is divided into phases, and to each phases is bounded a plugin, and you call in the plugin goal. So then Maven is very famous for dependency management. So in this case, everything is an artifact, and our dependencies we are using in Maven, they are also called artifacts. So this is a little wording, very important. We have to always keep in mind. Another big thing is concepts behind Maven. The most important is don't repeat yourself. So there is one solution. Just simply apply it. Don't do your own thing. Don't customize too much. The structure of Maven is very well proved. We have a lot of experience, almost more than 1 decade, dealing in enterprise projects with Maven. Don't change structures. Keep the standard on. You don't need to reinvent the wheel. So in this way, you can understand what means dry. Don't repeat yourself. Another very important concept in the Maven lifecycle or in the Maven context is convention over configuration. That means just simply everything in Maven have a default configuration, and you just have to write it down if you want to change the default values. So the default you don't need to notice in your build logic. So just when you change something from the default, then you need to notice or to explain what is the difference, no? So convention over configuration. And of course, all this together is keep it simple, stupid. Follow mostly the KISS principle. Because when your Maven build file on your structure get too complicated, you don't want to run around and try to understand what happened there. And this makes the things just very complicated. And in this way, keep it for you all simple, and that makes your life more simple. You don't need to express yourself or how cool you're able to deal with all the technologies. In this way, Maven always follow a very defined structure. So everything have a place where you can search for it on there are the things. As first, we have here a folder structure, mostly common. When I find my mouse, here. Everything starts in the root directory, and in this root directory is placed the POM XML. A little later, I will go more in detail what means POM XML. This, in the end, is the build logic, no? The project object model, and this describes how Maven is manage your project. So then we have a directory always will get generated during your build called target. Here you find everything of the processes. And when you call the lifecycle clean, this target directory simply get erased. With the next build, it's get recreated. So that's all. All the procedures you're doing, they appear in the target. So you don't operate in the original directories. If you're dealing with Maven site to create your own project website, you need here a directory called site and a site descriptor with the name of site XML. If you want to include their graphics and other things, you can do that in the resources directory. Very important then, we have here inside of the source directory the main folder. And the main folder is in the end where you can find our source code. And this is placed here, the Java classes in the Java directory. There is here something you don't see so often. It's called filter. In this directory, you can place property files. These property files can operate here in a directory called resources filtered or filtered resources. You can name like you want. How this is really working, I will show then later in the examples. This is something really, really new in the new Maven versions, because in the past, in old Maven versions, you just was having resources. But if you applicate in the resources a filtering, and this contains binary files, you get some errors. So now you have to split up binary and non-binary files for filtering. And if you're dealing with also Java Enterprise projects, you want to create WAR files, you have web application content, you can place here a web app directory. This is mostly common for packaging WAR. An equal directory structure you find in test, where you find where place your test files, even resources for tests, XML files, SQL, whatever you need. And this structure you always see in Maven projects, more or less, depends what you really need. And don't create everything when there is empty folders and you don't have a usage, you simply don't create it. So there is possibilities to change these structures, but honestly, I don't recommend you to do that because you make the things more complicated. And one other thing is there is a lot of other services you could use. For example, if you want to check your software quality with tools like Sonatype, with SonarQube. SonarQube operates in this directory structure. And if you change the things, you have to adapt all these additional services. And this makes a lot of work. You should avoid it. Stay in the standard. Now we are come to the Maven POM, project object model. This has several variations because in the end, it depends how your project is structured. Often you are seeing there existed a parent POM. This parent POM is included in other POMs. This parent POM includes then information about dependencies, about plugins, how the plugins get configured, and all the projects, they are using the parent POM as a parent with inheritance. They get all the information from the parent POM. Like this, you can little structure your project that your original POM is not that super giant, because they can grow really dramatically. So some 1,000 lines of code in a POM file is not in regular projects, is not untypical. Another thing is when you have a project structure with several subfolders, and these subfolders don't really use a parent POM, but you want to start everything at once, then there is no link from the project POMs back to the parent POM. And in this case, we call it simply reactor POM, because you can start from the reactor all the sub-projects, but when you start just a sub-project, then you cannot compile or build other sub-projects inside of this folder structure. So this goes just top-down. Different is when you work with modules, because then you have also the parent POM structure. The project POM is in this way. The parent POM includes the modules. They already contain a simple POM, and they get all the information from the project POM. And the build order of the projects is managed by Maven. You don't need to take care if you are having compilers first, module A, module B. You can change a little the order in the way you place the models in your POM. How this looks, I will show you then in the practical examples that you get an idea of what that means. So after we have an idea, there exist different POM variations. We will have here a look in a very simple standard POM. And this shows you a lot of things. So I include here a lot of information. So if you have a POM, they depend on another POM. You find here this part of parent. This shows you if the parent is not available, your build will fail. This happens very often in projects. So to overcome these problems, you have to change a little your CI strategy in Jenkins or whatever you use for your CI process. A regular POM, a simple project, just contain these entries from line 9 to 12. So here we see there exists something like group ID, artifact ID, and version. Like this, you can identify an artifact. And this identifier we call GAV, or parameters. No? The combination of group ID, artifact ID, and version number is the coordinate where you can find the position of your artifact. And here, of course, in additional, we need to tell what kind of artifact we are dealing when we have our project. In this way, it can be POM. For example, it's just a parent POM. This don't contains any other sources. Then we have the packaging POM. Or in the case we have just regular Java archives, then we place here Java or ERR to get then as a result, for example, a jar file. If I have a multi-module project, then I can add here this section of modules. Here you see module. As much modules I include, the order of this can have a little effect to the way how you process or how your build is started. But this everything what needs as first to build it, Maven manage this, because Maven know about all the other things written in the submodule POMs, how to start it, what are dependencies, what are relations. So you don't need to care as much about this. But be careful when you deal with this module project structures, because then you always have to check out the whole source code. Yeah, you cannot do just a module, because then it's missing some other information and you simply cannot build your project. So with this, you already see a simple POM. Yeah? In the end, just the line from 9 to 12 is sufficient to define your project. Of course, you need something more. You have to include your dependencies. Here we see an example for JUnit, a test dependency. I place here JUnit 4. You should not use anymore JUnit 4 because JUnit 5 now is standard. But I wanted to show just the mechanism, and the real example for JUnit 5 is minimum include 2 dependencies, the JUnit runner and the JUnit itself. So, and here is not sufficient space. But you can see here, these are the minimum POM information we need, our gov parameters, and the sufficient dependency, in this case JUnit. And this is just available when we execute our test cases. All the dependencies, they have the scope test. You will not find in your final packaged artifact. They are not included. If you don't define a scope, the dependencies are available in the regular build process and even for test cases. So then they are, of course, included also in the, in the artifact. They are regular dependencies. If you don't want to include your dependency in the way like, I just need it here for compile, and I don't have it there in, or I have the sufficient library then there in the environment I'm using, then you place here as a scope provided. If it's opposite, you don't have a dependency, but you will need it in runtime, you set the scope runtime. And this is the most typical cases you need the scope. If you want to check more, there is a good documentation in which scope you have which class path environments. So then just have a look in the Maven documentation. It's very well explained. The most cases is just scope test, runtime, or provided. Usually you don't need more. So this is the regular dependency management. Of course, when you have a parent POM, you can write here instead of dependencies, dependency management, and the rest is the same. And then in your sub POMs, you just call here the dependency notation, and then you don't need to write down anymore here this version and scope. You just place the artifacts, and then it's more easy to update. And of course, if you have a multi-module project and you say one module needs JUnit 4 for legacy and another needs JUnit 5, you can override it. We will see this a little later in the examples. Very important is in Maven to understand a little the build life cycle. I already explained there are different phases. So the most important phases we are getting in touch with is this. This tells us the number of the phases. For example, number 15 is test, and of course this execute the test framework. Now you configure in your POM. In the example we was having, simply JUnit 4 will get executed. Number 17 is package. And of course, this create in the end our jar, var, or ERR file, depends what you have there, ready for deploy. Something very new was coming is verify. This is for integration test. Maven, a lot of you maybe know the Zurfire Maven plugin. This is for unit tests. And now they have this fail-safe plugin, this bind integration tests. And then you can distinguish a bit between, and you can deactivate integration tests because they could be very slow in your build process. And verify is executing the integration test. After verify, you can say install. This places the artifacts in your local Maven installation. The most of you know this is this .maven2 directory included there, repository where all your Maven artifacts goes inside. Then you can reuse in your local environment. If you want to share with other departments, companies, persons, your artifacts you have to deploy. This can be in a repository server. It's just available for your company or for a special community, or you deploy to Maven Central. Then it's for the whole open source community available. How we do this, you will see in the later presentation I will have here today how to deploy to Maven Central. Then we touch exactly here the part 22 and the part 23. So very important is you can execute all these kind of things from the command line. That means you can say, for example, Maven install, and that's all. This is just execute all the 22 phases they are before in the defined order of Maven. And in the end, you have your package, and this will be copied to your local repository. If you just want to test without packaging or something, you just type mv test. That's all. If you have a plugin you want to execute separately, you just call it by phase, plugin, and goal. Okay, I have here some examples. You can see the first we was talking about here is the Maven Phases Maven clean, site, package, verify, install, deploy, and here with the parameter X. This X activated debug mode, and then you can see much more things. I will show you this here in my NetBeans. NetBeans I use because this have a very nice support for writing Maven POM files. So as first, now here I open the terminal in NetBeans. You can see here Maven version. I currently use the newest 3.8.4 with Java 11. Well, one day I will update to Java 17, but for this I will wait a little more until more persons have experience. So I'm now here in a project called Samples and Trainings. Let's have a look. What is there inside? There is a subdirectory called token replacement. We will go inside cd 01. So there we inside, and now we can start Maven. We just type here mvn install, or maybe package, and we give the parameter X to get all the debug information, and I run it. So, and now you can see what happened here. A lot of information is running down, build success. That's all. And the same you can do now if you type, let's have a look here in the directory structure where I was working. Here I included this in my projects, and here you see the target directory where everything appear. Now let's see what happened when I type Maven clean. Build success, and the target directory disappear. So like this, you get a little idea about the basic usage of Maven. And these commands you usually applicate in your continuous integration server like Jenkins or whatever you use. If it's Bamboo, it's quite the same. So there we have now this example on how to call a regular phase of the build lifecycle, or how to call directly here the Maven clean lifecycle or the Maven site lifecycle. A lot of projects, they are using Maven clean install because you can combine this. You should not do that because this slow down your build. The better way is now to use Maven verify. Is a recommendation of the Maven developers. They say you will have now much more performance, because with the clean you always jump over caching and other things, and so instead use Maven verify. It's much more fast and the same secure like Maven clean install. So don't use it anymore. Change to Maven verify. Because Maven, as you could see here in our overview of the build lifecycle, verify really enable everything in the package, and then you are in the integration test phase, so you get a better performance. So another thing is when you have in your POM defined some plugins, may you want to see them directly, or you want to execute them. This you can do like this. Now we have here the version plugin. We have here the display plugin updates goal. Just we call it like this. Let's see, because always when you try something happen. Okay. So now you see all the things they are not available. I'm downloading here. In this case goes my own repository server I'm using. And after the download is done, it's available in my system, and the project get executed. So this takes here a little. And after this is done, we should see something. And of course, we applicate this in the directory where is our POM located. No? That means you can find it here in the directory 01 token replacement. And before you have some questions, this project is available in my GitHub repository. Just go to GitHub and have a look or search for Elmo Dot. There is all my work available, and you can use these examples as you want. So here you can see everything is executed, and this command we was using is simply to check our dependencies, and here you can see what is used and how this is configured. So this is the execution of this plugin. So we called directly the plugin, and we also this is the plugin name, versions, and we execute the goal display plugin updates. So the same we can do when we are dealing with profiles, to tell our Maven which profiles we have. You just place here P, and then you could add as much as you want profiles here. They just have to be available. So in this case, it's execute the Maven goal package, or the phase package of the build lifecycle, execute the two profiles, release and javadoc together as first release and second javadoc. How to deal with profiles is a little tricky, but you can define them in your POM and execute them directly with this command. Then, of course, we are able to override existing properties. For example, the test cases of Zurfire have here a property called skip tests. Is a standard. Doesn't matter if this is included or not. And when I now are in a release process and something get wrong, I have there a test execution of 15-20 minutes, and I know this text execution is fine because I was fixing something after this, I can skip this without touching the POM. I just call here Maven package or Maven install as I want, and then I say -d, and then I add simply the property I want to manipulate. So if this is not a built-in property of my build lifecycle, like here skip tests, then I have to have a look if this is really a defined property. And then I said simply here skip test true, and then all the test execution get skipped. This is very helpful several times. Maybe we can show that later here. Yeah, I will show that a little later when I go then to the direct examples. And of course, Maven have another definition where you can place important information. This is called settings XML. The settings XML is usually available in your Maven installation, but you can keep your own Maven settings XML. There you store access to servers when you, for example, want to make a deployment. You store credentials and the way to store credentials is a bit tricky. But for example, if you have here a local environment and you want to run your Maven locally, you just call it Maven package. And for example, your build server like Jenkins have their own settings XML and you're a build manager. Just copy the content of the settings XML to your local environment, and then just say, okay, I want to run the Maven settings like from my Jenkins, and I tell them here with the parameter -s and the path to the full settings XML from Jenkins, and then I see, okay, this is working very well. You don't get there in giant conflicts. In this way, when everything goes fine, you see always here appear build success. This is a very old screenshot. You can see how long I'm dealing with this now. It's from 2012. And in this time I was working with Windows. Now I'm more into Linux systems. Is one of the biggest benefits now that Maven as a Java implementation is completely platform independent, and always the result you do is the same. As long you define it very well in your POM and you keep the standard. So now let's have a look to some practical things you can do with Maven. The most of this is very standard, but unfortunately, not so many persons know it, how to do it, because they are just having mind in coding. They just execute the build inside of the EDI. And if there's something wrong, they don't know where to search for the problems. In this way, I like always to cite Gardibu, the founder of or one of the founders of UML. He always say, a fool with a tool is still a fool, and we are not fools. In this way, I'm here giving you some examples with Ubuntu, NetBeans, and Maven. So let's have a look here. In our first mini project, it's talk about token replacement. Here you see how a property is defined in Maven. You just use the property, and properties are nothing else than variables. In this property section, you just type here an XML tag, like your property should be named, is the property name. And inside of these two tags is included the property value. That means we have now here the property file with the value DBMS properties. So in this way, we apply now a filter. Our filter is placed in source main filters, like we already told. And here we replace it for the DBMS properties. Because this mechanism we will find now again in our filters, because the filters also deal with properties. So then, of course, we have to say which directory contains the filtered resources. And keep in mind, now in the new Maven version, you get in trouble if the resources folder contains also binary content like images, for example. Then this filtering fails. So you have to split it up. This is also why I like to deal with NetBeans, because here you can see this already structure me my project. Here I find the source files in a very compact way. Here I have other sources, and you see here the directory filters and the DBMS database management properties. Voila, they are here. And this is just a key value. For example, we have here GDBC main schemata with the value together. And this I want to replace inside of my application here in the resource. The GDBC properties gives me the connection to my database. And I have to say, okay, this is my filter file. DBMS properties is the original. And here, this property, GDBC main schemata, get replaced exactly with this. That means here in GDBC properties, this content will be together. The value will be together after I execute it. The mechanism is for source files, the same like for test resources. If you have here another directory with, binary files, you just include it like this, only set filtering to false. And even you are able to have here more property files. When you say, I have to configure an email service, I have to leave there some information about my SSMTP server, just split it up in different files. This helps you later in maintenance. So that's simply all. When we are checking here, I already was executed this. In the view, there is a token replacement. I just want to execute it now here. I just call it in the IDE. Voila, Maven is running. Build success. And now have a look here in target. What we see is the resources get later copied also here inside. You have here the compiled class, and here you have the property file. We applicate the filter, and voila, you see now there is all the values I was using from DBMS properties. So I make it a little bit bigger, then you're able to read it. So simple like this is just token replacement. One thing you have to keep in mind, token replacement don't work in your Java class files, because the problem is you should when you have a class file and you want to make a token replacement inside of the class file, this class file have to make as first process the token replacement, then have to get copied in the position where the compiler is making the includings of the classes. And in this way, you should not do that. You should use other mechanisms. So it's not working. You put the class file here into resources, then make a token replacement, because the result you get is just simply here the copied Java file, class point Java, and not the class file like you expected. In this way, because here you see there is later the I'm here in the source folder, here in the target. Here's this. If I just have this Java file, then would appear here class point Java. This don't work. So there's just a way to make two compilings. Some other heavy things, don't do it. Just work with regular files and include this information then later dynamically with a property reader in your Java classes. And then you keep the things more easy. Another thing, when you're dealing with Maven is during the compile. So let's see, clean the old, you can see it's possible everything to do there, but currently I don't see, I'm in the wrong view. So here, let's clean, voila. So now it's virgin again. The next problem we have is compiler warnings, because when I work with Java, sometimes could be great to include compiler warnings during my build process. Then I get to know if there is some issues I should take care of it. For that reason, you have to include in your build lifecycle, it's here in the plugin section, the Maven compiler plugin, with the configuration to say, okay, equal alt, show warnings true, and show deprecation true. And when you run now this, because I have here a little Java class application, we will see how this is working. The build get holded, but of course, is still success. We create a package, but we get here some information, and I can double click, and I say, okay, here list, I should do it a bit better. No, something like this. Let's see what we have there. It should be string. Here we add a diamond operator. Then we reuse it. Probably this is getting better. just less warnings, and this appear now here because I was doing a mistake. Okay, it's like always. If you try to show something, something went wrong. Never update your system. I was not configure here the Java version, and it tells me here very clear diamond operator is not supported in Java 6 because this is default. And I could now change here the way to say destination, the source we want to compile, Java 11, and no, it's not out. I think this is sufficient. And with this now, if I didn't a mistake, no, is not complete. Nevertheless, you can define here with these sources. I have it somewhere here. This is copy and paste is always programmer's best friend. Compiler plugin source and target I have to define. Voila. So here we have a property, but I can just say it like this. And now it should work. Exactly, because Java 11 allows the diamond operator. You see, it's very helpful always to have compiler warnings when you take care of good, good software quality. Because especially here, these things with the generics is really an issue. Sometimes when the persons are not so fluent in Java, they always get these little mistakes, and of course your code get more secure, more stable if you deal with these additional informations. Okay, this is just how to create compiler or how to show compiler warnings. We get a little late. Executable jars is nothing more complicated than this. We just have to tell in the jar plugin where is the main class, and we have to add it to the class path. This will be here samples Maven application. That's all. After this, the jar is executable. Voila. You can see here it's running, it's working. Yeah, remind it's just here, just in the jar, attach the main class. In this way, I was doing here something with swing that you can see the window. Another thing you could check is enforcement, because when you do releases, you should not want to have snapshots dependencies because they are not secured that they're, or it's not secured that they are not changed between two builds. And to secure that you have the correct Java version, Maven version, or no snapshots, you use the enforcer plugin with two goals in this way. I bind it here in the files validate very early, because I don't want to run everything and then in the last step after executing tests don't make sense then to say, oh, no, this don't fit my expectations, I skip. I should do that very early. I want to see my display infos, what is the problem, and in the case there is something, go enforce. Let's execute it here. There we see a failure because I deal here with snapshot. I told here is not allowed. Required snapshots version, snapshots not allowed. This is just a message we see here down. this is the nice part. In the way I just change here the snapshot, everything goes as well. You see, build success. You can configure this plugins in several manners. One thing is, for example, the enforcer could make a hold because of the enforce, or you just type out the display info, then it's not stopping. But it's very important if you really prepare releases, use the enforcements, nothing get wrong. Another thing is here unit testing or testing in itself. Here you see all the dependencies, Maven failsafe and the Maven Surefire. We are dealing here with two properties. They allows us the tests to skip in the case I want to speed up a little my build and I know everything goes fine. Here I have some nice test libraries. In this case is JUnit. Just execute, that's all. So everything is fine. Tests run one, everything is ready. To include tests, it's not more than just include here the framework you want to deal with this, in my case the unit, and here include the Surefire and maybe failsafe plugin. Different is unit tests have as a pre or post fix in the class name test, and integration tests pre or post fix IT. You can see that here, test packages, there is placed our test, and here we have the test and the IT. This is a little double because this means just IT. Okay, this is the way how you can deal with test files. Multimodule is the same. Here you can see that there are the modules we are dealing with, 2 jars and a web application is binded as a war. Here on top, this is our POM, some properties, build management or plugin management. These plugins we are using, and they get resolved here in our modules. I have to open them, these two. This goes a bit more easy if I do it just like this, then I don't reload it. Here you can see the parent POM is our main project POM. With this, when I'm now here in module, I just execute here inside of the module on compile. You see the whole project get compiled and not just module 1. In this case, don't have dependencies. Module 1 is independent. Let's show with a war, with a web app, because these include both. You can see that here as a Jakarta, module 1, module 2, and other things. And if I execute this now, okay, we are coming to end. Then everything goes fine, and you see here all then they are executed. So yeah, this is the main tricks about Java. Of course, we can continue several hours more. I could show you. I hope you were seeing a lot of interesting things. Thank you for paying attention. Maybe if you want, you can contact me in Twitter at Elmar. And if you have some questions or you want to start a discussion, then you're welcome. No escucha.
Hola, hola, Marco.
Perfecto.
Hi. Sí, Maven, una tecnología base, base technology para trabajar con Java, requerido casi en todos los proyectos. We have a couple questions.
Of course, yeah. Then
first, I show you on the screen, jar. Where? This way. You can see.
Yeah. No, when you have dependencies you are not using, you have to uncomment from your POM. Yeah, like here, a plugin you are not using, there's two ways what you can do. The biggest problem is when you're in the plugin management. Here in the parent POM we see that everything in the plugin management just get in usage when you call here plugins like this. Yeah, then it's really used, and then this affects your build. If you are just having here these management sections, like with dependencies, if I change this here to dependency management, typo, dyslexia, when we need all. So if I have it like this, for example, here you will see it. So now you see why I prefer to deal with NetBeans, because it supports me extremely writing their POM files. So now the bean matcher is not anymore in the process of usage. You can see that here when you are in a multi-module, there is test dependencies. It's not reloaded, but this then disappeared there. And if I want to include it now, I just have to use in the other projects or sub-projects where I'm running, like this. And then when the dependency mechanism is working, it's get this information, gather this information, and just places inside. So clean, just erase the target. And of course, in the target is placed also your dependencies. Yeah, you can see that here the target classes, where we have it. There's a little here somewhere you should find them. When there is dependencies, you find that there somewhere generated. I don't have now here a sample of where this is available, but you just erase this copy of dependency.
Yeah,
you can see that here. Okay, hopefully.
Yeah. Next question. This.
Yeah, if you just work with Maven, I really recommend go to NetBeans EDI. Now this you can see here is the most newest 12.5, have dark mode. You have here cool things like graph. Okay, this takes now a little too long, but you can see also here effective POM. I'm now in the better here in the module POM is related with the parent POM, and I don't have there a problem, and I want really get to know where it comes. No, I go here to effect and I see module POM. This entry comes from module POM. Here Maven POM builder gets there. The parent POM includes me here compiler plugin 3.81. This is a very helpful feature for build managers. They really deal just with this. I never see something equal in other projects, and even here with the suggestions in the configuration section of the projects. Okay, NetBeans.
Finish. Time is over. Any book to your recommendation from your recommendation?
Yeah, my recommendation: NetBeans. Always NetBeans. If you deal with Maven, NetBeans.
Any book about Maven?
Yeah, my book. Oh, sorry, I was not hearing as well. But unfortunately, it is written in German. There is not really so many Maven books. You can deal with because the most of the resources in Maven, they are free available. Just use Google. Here you can see when this is going. Okay, there is a big section about build management, but unfortunately it's just in German language.
Good, very good. Bien. Bueno, chicos, ahí tienen también un libro que lo recomienda Marco para que ustedes puedan perfeccionar lo que tiene que ver con Maven. Recuerden que Maven es una parte fundamental de desarrollo en la tecnología Java. Bien, llegamos al final de nuestra presentación. Muchas gracias, Marco, de parte de Perú y de toda la comunidad latinoamericana de desarrollo Java. También muchas gracias. Bueno,
gracias a ti. And maybe see you later in Deploy Maven.
Deploy Maven. Abajo Gradley. See you later. Thank you very much. See ya.
Gracias. Ciao.
Buenas
Sí,
tardes a todos, sigan disfrutando con el JConf Perú 2021 y seguimos en línea.